So we use completing the square to help us solve quadratic equations that are not factorable. So I'm looking for what x value would make x squared plus 6x plus 2 equal to 0. And there's no way I can try to rearrange the equation to get 1x by itself and figure out what x is, because there are two terms of x's. And if I try to find factors of 2 that adds to give me 6, I wouldn't be able to find any. So in order to solve this, I would have to complete the square and force it to be able to factor somehow. So let's complete the square by temporarily moving the 2 over. So I would have x squared plus 6x, and I'm going to temporarily move the 2 over, so negative 2. And to complete the square on x squared plus 6x, I'm going to try to add another term to it in order to force it to factor into a perfect square. And whatever I add to the left, I have to add to the right. Right, so what we're adding in there is b over 2 squared. So in this case, 6. So x squared plus bx is what you're using to complete the square. And you're trying to add a new term to it. And what you're adding in is b divided by 2 squared. Alright, so 6 divided by 2 is 3. 3 squared is 9. That's what I'm adding in. You could put 3 squared or you could put 9. Okay, and so that allows me to factor this. Now this is factorable, and it factors out to x plus 3 and x plus 3, so x plus 3 squared. And then on the other side, I have 9 minus 2, which is just 7. And now I have this x here. I could try to isolate this x. I now only have one term with x's, so I could undo the exponent and move that 3 to get the x by itself. So we're going to take the square root of both sides to undo that square. The square cancels out the square root, and on the left side I have just x plus 3. On the right side, the square root of 7 is an irrational number. It's going to be a decimal that runs on. So instead of putting it into the calculator and estimating, we want exact answers. So we're just going to leave it as the square root of 7. But whatever that decimal is, it's going to be a positive or a negative, whatever the square root of 7 is. So the square root of 7 is what plus or minus whatever the square root of 7 is. And then to isolate that x, we're going to subtract 3. And so x is equal to negative 3 plus or minus the square root of 7. It's also okay to write it as plus or minus the square root of 7 minus 3. Usually we put it in the front, just so we don't get confused whether that negative 3 is inside or outside the square root. Okay, and so if you were to estimate what x is, you would type into a calculator negative 3 plus the square root of 7. That's one answer. And negative 3 minus the square root of 7, that's another answer. So you have two answers. And you can certainly use these and substitute it into the equation and make sure that if x was negative 3 plus root 7 squared plus 6 times negative 3 plus root 7 plus 2, that gives you 2. That gives you 0. So completing the square is a method that always works. Regardless of what kind of quadratic you have, it will always work. It's a little bit more work than factoring, and a little bit more work than undoing PEMDAS, but it will always work. And I would use this if I have a quadratic that can't be factored.